Alright, this is John Black, super chemist. We're going to make some chromium 3 chloride or chromic chloride. There's my apparatus. I got a equalizing funnel up on top that goes into a round bottom flask. As you can see on the left there, it's got a little valve that goes to a hose. And if you saw one of my previous videos called a gas scrubber, you'll know what it is. Leads through all those bottles, which I have sodium hydroxide in 2 of those bottles. And right there where the funnel's at, I have water. So any HCl gas that escapes or the hydrogen I'm going to make, it'll go through those bottles and scrub out that HCl. So I won't have to breathe it. You can see I got my stir plate, my stir bar inside there. And basically I'm going to put the HCl up top and drip it in. There's on the left, I got 1 mole of chromium metal powder, which is 52 grams. On the right, I just have regular muriatic acid, hydrochloric acid I bought at the hardware store. I'm going to put 200 milliliters in there. That's 2 moles. I really need 3 moles to do the experiment, but we're going to start off with 2. Put it into the equalizing funnel. And when I drip this in, I want to drip it in very slow. This stuff is going to produce hydrogen, and I don't know if you've ever seen the volcano experiment where they do the baking soda and vinegar, and then it comes up, they mix it, and all this stuff comes out of the volcano. Or if you open a can of pop, Coke, and you shook it up beforehand, all that CO2 is trying to get out, and it makes that effervescence. And basically that's what will happen here. So I want to drip it in nice and slow. As you see, I got the metal down at the bottom, and there's my tube there. I'm going to start dripping it in. That's actually probably dripping too much. I really can't start the stir bar yet. Although I think I do have it started up. It's just wiggling back and forth because it's basically all that metal dust and no liquid. At this point, I'm thinking, it should be bubbling through there, and I don't see any bubbles. Now I'm starting to get paranoid. I wish I would have left the volume on for this, because what happened was it built up all this pressure and popped off the cap onto the top there. It smashed in it. I mean, it was loud, big pop, scared the heck out of me, and broke the keck clip, the piece of plastic that holds on that cap. Right now, I'm running around like a chicken with his head cut off, trying to figure out what's going on here. There's that keck clip. See what it did there? It smashed it right in half when the cap blew off. Anyways, there's the culprit. I thought it was the bubbler I made. It was actually that little valve there. I forgot to open it. So it kept building up, making the hydrogen and building up the pressure. So now I'm real paranoid, about turning it up. So I'm dripping it in real slow. I do have some liquid in there now, so I can start to stir it a little bit. And you'll see now, see how I got the bubbler going. And if you look on that where the funnel's at, you can't see the bubbles comes in because they're behind the funnel. But when it bubbles on the right in that bottle, you look at the left at the funnel, the water, it flows all around the place because it's just going from one bottle to the next until it gets to that funnel. And by then, it's just hydrogen and, air. Yeah, that's actually too much bubbling. I'm just turning it up so you can see what it's like. So I'm back to it. I'm trying to get the drip rate slow. I don't want to, go too fast. That's basically all I'm doing here is I'm just dripping it in there, letting it spin and react. This happens. This is, it produces heat as it goes. I'm not heating that at all, and you can see it's already 73 degrees Celsius. And look at what happened. I went too fast. Wish I would have had this tape, but in a way, I'm glad I didn't, because I would have ran over my camera trying to grab up pieces to try to direct that foam into somewhere. If I would have had a piece handy, it would have been no big deal. But you can see that whole round bottom flask is all filled up, and that's all mostly air. It's just foam. Like when like when you do a can of pop, all that foam comes out. It's a little bit of liquid, but most of it's just foam. And if you watch here in a couple of seconds, it's just going to fall halfway down. I'm not going to let you watch it all fall, but the major big fall, it's pretty cool to fall down. So I got all those pieces that had the foam on it, and I put them in water and collected it all up so that I didn't lose any product or whatever. And that's probably going to fall in about the next 3 seconds. Oh, 2 seconds. You can see at the bottom there, that gray part, it looks like 2 layers, but that gray part, bottom layer, that's just a thin film or thin layer. The spin bar pushes it up against the sides there, and it looks like it's half full, but it's just a layer. Now I told you I needed 3 moles. I only put in 2 moles of HCl, so I'm going to put in another 2. That'll be an extra mole. And if you think about it, I probably need more than that, because the first 2 moles are going to be reacted, and I'm only going to have water. All that HCl is going to be gone. And so I'm really going to have dilute HCl, hydrochloric acid, when I put this in, and it mixes together. It's not going to be very strong. And my mistake was that I thought it was a ratio of 1 to 1. So I was thinking, well, I'm putting in 4 moles to 1 mole of metal. That's plenty. And at the very end of the video, I did the math, and the stoichiometry is different. It's a 3 to 1 ratio, not a 1 to 1. So I start dripping it in, and everything else goes pretty good. Once I get that all dripped in, I'm going to add that. Remember how I said I cleaned out the pieces that got when it overflowed? I cleaned those pieces out with water. That water I added to the pot. And here I put it all in that round bottom flask to the left. You can see I have my heating water bath. It's a simple distillation. And up on top, because this is going to, I'm not even distilling water. I'm distilling dilute HCl. So the HCl is going to go through my bubbler there and get scrubbed and come out just air and hydrogen. So I'm going to raise my mantle and heat it up. I actually had to redo this whole thing on the stove, because I needed the flame to get the water hot enough. On the right is the dilute HCl I boiled off. That's basically the extra water I put in. I wish I wouldn't have put that, had to clean all that up. And on the left is what I would have if I didn't put all that water in there. You can see it has a pH of 1 or lower, but it's probably real dilute. Now when I get done with this, I distilled it, so it heated it up and made it really react. So there's not that much metal left in it, but I want to filter it anyway, because there is some in there. And you'll see after I filter it, a slight layer at the bottom of the funnel. I mean, the stir bar and the boiling chips, they just look like they're on top of it. They don't look like they're in it. You know what I mean? So it's a real thin layer. And what I'll do is I'll collect that out, and that dilute HCl that I distilled, I will throw that metal, the little bit of metal powder, into there and just let it sit for months or weeks or whenever I do it again. I didn't use a vacuum. I just let it drip in there. I ended up with about 800 milliliters of liquid there. You can see right there the gray. That's actually white on the bottom of there, but the gray layer is the chromium powder. And you can see I threw some more water in there, and none of it turned green. It just turned gray, and that's due to the powder is, it's floating through the water there. If I let it sit, it'd clear up. So I took 5% of that 800 milliliters, because my objective is to make potassium dichromate, not chromium chloride. So I took a little bit out just to show you. Basically, what you do is get it saturated and get it almost boiling. And at that point, take it off the heat, let it cool down, and then put it in the freezer and let it cool down. But don't let it freeze. And whatever crystallizes, filter it off, and there's your product. Now, I did this, and it stunk up the room. Uh, chromium, heated up chromium is terrible. So I stopped it. But what I usually do, because I have made this before, is at this point, I just put it out into a plate and let it evaporate naturally. The slower you do it evaporates, the more pure your stuff is, so you can't lose. But it does take several weeks. So if I had any suggestions about this experiment, I would say to uh, be prepared for overfoam, go very slow to get it all to react. Heating it up to distill it, that's great because it really helps the reaction go forward. There's the math if you want to check it out. You need 2 chromium metal atoms for every 6 hydrogen chloride atoms. So that's a ratio of 1 to 3. I don't want you to keep in mind that we're trying to make the chromium chloride, but there's a side product of that hydrogen. There's going to be a lot of it. Think about it. We're doing 1 mole of chromium, and in the formula it says 2 moles. So we're only using half of what the formula says. So when you look at hydrogen, it says 3 moles of hydrogen, but we only used half the amount. So we're only going to make 1.5 moles of hydrogen. Now, how much space is that? How much volume does that take up? Well, 22.4 liters is how much 1 mole of gas takes up. Now that's an STP, standard temperature pressure, 14.7 psi, which is weird, 0 degrees Celsius, and that's an ideal gas. Keep in mind, so you multiply that by 1.5, and you would get 33.6 liters of hydrogen gas you're producing. And if you're American, that's about 8 gallons. I mean, I'm just guessing, but it's give or take. But it is 33.6 liters. So that's just to let you know. Well, I boiled it down to 20 milliliters, a little bit less. And I put it in the freezer overnight or the refrigerator, and it solidified. So I added some more water, and you can see there I'm dumping it into a crystallizing dish. I'm going to clean that out, make sure the water is crystal clear, because if it's any tint of green, then I have some more salt in there. After weeks, it finally solidified and crystallized out. I didn't really do it the correct way. I just let the water evaporate, and whatever was there was there. You should pour out a little bit of water. That way that you get rid of the impurities, if any. I'm going to take a little bit out and crush it up so you can see it. The color does not do justice on a film. Now, if it's anhydrous, it'll be a purple, a real dark purple. I made hexahydrate, which is 6 water molecules incorporated into the crystal lattice. So it's green, and it's a real dark green. You can see on the glass there where I chipped away, it's a little bit lighter green, but the crystals themselves are real dark here. The reason I didn't give a yield is because this kind of thing is almost, quantitative or whatever you call that, uh, where you're going to get like almost 100% yield. And what you don't, you got that little bit of chromium that you scrape up at the end, the metal that didn't actually react. So you'll get a really good yield. But I don't want chromium chloride. I just want to show you how to make it. What I want is potassium dichromate, and I wanted to make it from the metal. And sooner or later, of course, I want to make the metal from extracted out of stainless steel. Anyways, keep in mind, and always remember, science is great.